Okay, the third subtopic, force on a moving charged particle in a uniform magnetic field. So in this subtopic, you should be able to explain and use magnetic force, determine the direction of force, describe circular motion of a charge in a uniform magnetic field, and use the relationship this. Okay, so force on a moving charged particle. So magnetic force, a stationary electric charge will not experience a magnetic force. Okay, so if it's stationary, it won't experience a magnetic force. But if the charge is moving, it will then experience a magnetic force. Okay, so the magnitude can be calculated using this equation here. All right, so the theta here is the angle between velocity and magnetic flux. Okay, make sure you know that. And then in vector form, force is equal to Q and the vector product of VB. Okay, so the direction of the magnetic force can be determined by using the Fleming's hand rule. Okay, so for negative charge, we will be using Fleming's right hand rule, whereas for positive charge, we will be using the Fleming's left hand rule lah. Okay, so the thumb is pointing the magnetic force, whereas the pointing finger is pointing towards the direction of magnetic flux density, and lastly the middle finger is pointing the velocity, direction of velocity. Okay, so motion of a charged particle. Consider a charge moving in a uniform magnetic field with its velocity perpendicular to the magnetic field. Okay, so it is perpendicular. As the particle enters the region, it will then experience a magnetic force. Okay, look at this one here. It will experience a magnetic force, which the force is perpendicular to the velocity. So perpendicular, hence the direction of its velocity changes, but the magnetic force remains perpendicular to the velocity. Okay, so even though the velocity is changing, the direction of the magnetic force will not change. It will remain perpendicular to the velocity. Okay, this magnetic force makes the part of a circular motion. Okay, as you can see, it actually moves in a circular motion. Okay, due to that, we can then equate that magnetic force is equal to the centripetal force. Okay, where magnetic force is this equation and centripetal force is this equation. And remember, the theta between the angle between the velocity and magnetic flux density is perpendicular. Okay, so theta is equal to 90 degree. Okay, and then what else? So from there we have this equation lah, so we can calculate R, which is the radius of the circular path. Okay, so Q here is the magnitude of the charged particle lah. Okay, that is for radius. And then for the period of the circular motion, the period can be calculated using this equation here. Okay, and then the frequency is just this lah. Okay, all right, that is the theory part for our third subtopic.